Yeah, once it is done, please let me know so that we will start solving the.
Yes, sir. Completed.
Okay, good, good. Okay. So what about other students? Have you completed drawing this figure?
Yes, sir.
Yes.
Yes, sir.
Okay, okay, good. So the question asking here is you have to find the currents in a given network. So, but this network circuit is combination of independent voltage sources and dependent voltage sources. So in this, we have 5 volts as independent voltage source and 10 volts as independent voltage source. And we have two rhombus shape symbols sources. So rhombus shape means we say dependent source. So this 10 into IB, we have a plus minus symbol inside rhombus. So it is a source of what? Plus minus means voltage source. That voltage source is controlled on what? 10 into IB. So this particular source
Current.
is called, yeah, this is called as current controlled voltage source.
Voltage.
Yeah, CCVS, okay. And similarly, this one also the same thing. It's a voltage source controlled by the current. So again, this one is current controlled voltage source, CCVS. So we have total 4 sources in this particular problem. And the question asked is we need to find out the branch currents. That's the question. So we can solve this particular problem by using mesh analysis. That is one method. So we'll try to solve by using mesh analysis. So here for considering mesh analysis, we need closed loop. So we have one closed loop and we have other closed loop. And our assumption is considering currents in clockwise direction. So I'm assuming first loop current as I1 and second loop current as I2. And according to this particular problem, so this IA direction is not assumed by us. It is by default given in the problem statement. And this IB direction is already mentioned in the problem statement. Many students used to change this IA and IB. Don't do it, never do it. Because those IA and IB values or locations are mentioned in the problem statement. So this I1 and I2 are our assumptions. We are assuming loop currents are in clockwise. Those loop currents are I1 and I2, okay? So according to given problem statement, can I write I1 is equal to what? IA? Can I write I1 is equal to IA? Any difficulty while writing I1 is equal to IA?
No, sir.
We are just writing this particular loop current, we are assuming as I1. But in the question itself, they are given the current flowing in this particular loop is IA across 5 and 10 IB and 5. So I'm writing I1 is equal to IA. And similarly, I can write I2 is equal to what? I2 is equal to IB. Second loop assumption is I2 and already IB is the current flowing in the same loop. So I2 is equal to IB. So these two, yeah. Is it okay? I2 is equal to IB?
Yes, sir.
Okay. So after considering these two things, what I can do is I can apply mesh analysis. Applying mesh analysis means KVL plus Ohm's law. So KVL means summation of voltage is equal to 0. And we are going to consider Ohm's law, V is equal to I into R. So by using these two formulas, we are going to write the loop equations. So here we are having 2 closed loops. So I'll be having 2 equations of 2 unknowns. I1, I2 are the unknowns. So what is the first loop equation? Loop 1. What is the loop 1 equation? Please tell me, anyone? If I'm starting from 5 volts, what is loop 1 equation? So generally for mesh analysis, I will just recollect you. We won't assign plus minus symbols to voltage source or current sources or any sources. And we will assign only plus minus symbols to RLC. So since we have only resistor, so we are going to assign plus minus only for the RLC or only R in this particular problem. And we won't touch any dependent source or any independent source or any sources at all. So for the first loop, what I can do is, so I can start from 5 volts. So my 5 is minus 2 plus, so it will be plus 5. And then for the 5 ohm resistor, it is going from plus to minus, so it will be minus 5 into I1 is the current. And then this particular 10 into IB is a voltage source. So voltage source means already we are writing summation of voltage. So the voltage source is I'm having from plus to minus, so I'll be having minus sign. And the voltage source value mentioned is 10 into IB. 10 into IB is the voltage source given. And then this particular 10 is a common between 2 closed loops. So and we are writing first loop. So we are assuming I1 is greater than I2. So we are going to get minus 10 into I1 minus I2. Then, and this 5 into IA is the source. Source we have already plus minus symbol. So we'll be having here. We'll be having here minus. So what will you get? Minus 5 into IA is equal to 0. Very simple equation. That is loop equation number 1. That mesh equation number 1. So any difficulty while writing the first loop equation? 5 minus 5 into I1 minus 10 into IB minus 10 into I1 minus I2 minus 5 into IA is equal to 0. Yes, any difficulty?
No, sir.
No, sir.
No, very good. Okay. Next, loop number 2. While writing loop number 2, again we are going to do the same procedure for the mesh analysis. So we can start from the common branch. So here, if you are moving in a clockwise, so that for 5 into IA, we won't assign plus minus to any sources. Please remember this very important step. Many students used to do mistake. For the dependent sources, you used to assign plus minus in clockwise symbols. We should not touch or we should not assign plus minus symbols to any sources. That is the logic we are going to consider. So here we are going to consider plus 5 into IA is a voltage source given, and then minus, here you are going to get minus 10 or plus 10 into I2 minus I1. Please tell me, anyone?
Minus 10.
Why? Because, yes, very good, very good. The reason is, for while writing the second loop, we have to assume plus minus to the each branch again in clockwise for the second loop with respect to second loop. So with respect to the second loop, I'll be having from plus to minus for the 10. So you will be having here, so minus 10 into I2 minus I1. Next, then minus 5 into I2 minus 10 is equal to 0. That is equation number 2. So for this particular 5, we are going from minus to plus, so it will be plus 5 into IA, and it's a common branch, and it is from plus to minus with respect to this polarity. So I'll be having minus 10 into I2 minus I1, and for this 5, it is from plus to minus, so minus 5 into I2, and given independent voltage sources from plus to minus, so it will be minus 10 is equal to 0. And already we are having I1 is equal to IA, I2 is equal to IB. So we can put these conditions in these two loop equations. You are going to get answers for I1 and I2. So those are the required values of branch currents. That is I1, I2 are the branch currents they're asking us to find. So you can find out the answers for I1 and answers for the I2. So please tell me answers for I1 and I2, anyone?
Minus 1 by 4.
Minus
1 by 4.
Okay, 1 divided by 4 amperes. Okay.
Minus 5 by 12.
Minus 5 by 12.